All right, so today we're going to look at section 2.4, okay, which is on solving linear inequalities. So eventually, as I said, we're going to get to more complicated ones where the graphing calculator can kind of help us out. But we might use the calculator a little bit today too. Right? But for linear ones, you really you don't need the calculator as much. Okay, so just a reminder of what the four inequality symbols are. So we've got less than or equal to, greater than or equal to. Okay, and these are examples of inequalities. Okay, the first one is just a true statement. Okay, 3 is less than 8. And the second one is more like a conditional inequality. Okay, it can be true if you pick the right values for x. Okay, but unlike an equation, there's an infinite number of solutions that make the inequality true. Okay, so how do you figure out if a number is a solution? All right, so basically, if you're looking at an inequality, okay, a number is a solution if you plug it in for the variable and you get a true statement. Right, so for example, if I asked you in that inequality, is 5 a solution? Okay, plug in 5 and see what you get for an answer on the left. So Tanya, if I plug in 5 for x, what do I get on the left? 15. And is that statement true if you plug it in? Yeah. 3 times 5 is 15, and that's greater than 12. Caleb, can you give me a number that would make that false? 2. Because if you plug in 2, 3 times 2 is 6, and 6 is not greater than 12. Okay. So any questions on how to check if a number is a solution to an inequality? So conjunction. So a conjunction is when you have two inequalities connected with the word and. So here's an example of a conjunction. X is greater than -1 and x is less than 3. Okay, so what we can do with that is we can combine that all into one statement. Can anyone tell me how you would combine what I have up above into one statement? Yep.
-1 is less than x is less than 3.
Yeah. -1 is less than x, which is less than 3. That's one way to do it. Or you could also do it this way. Put the x in the middle. Have the inequality symbols point the other way. And switch the numbers around. 3 is greater than x, and x is greater than -1. Okay, either way. I usually do it this way. Smaller number on the left, bigger number on the right. Both inequality symbols pointing in the same direction towards the smaller number. Any questions on that? All right. So for that inequality, okay, the answers are what we call an interval. Okay, and we've already been talking about interval notation. Okay, I kind of introduced it earlier on. You use the parenthesis and the bracket. And we'll talk a little bit more about interval notation today. Okay, going into some more specifics. But if you wanted to write the answer to the above problem as an interval, write it like this. That means you can pick any number from -1, not including it, because it's a parenthesis, up to 3, also not including it. If I had the equal to symbols instead of the greater thans or less thans, then I would use a bracket, because that means to include the endpoint of your interval. Okay, so there's what we call four types of bounded intervals. Okay, bounded means that the interval doesn't go to infinity. Okay, it means that your interval actually has numbers, okay, as its endpoints. Okay, the first example is what we call a closed interval. Okay, fully closed. Closed on the left, closed on the right. Means you can include A as part of your answer, and you can include B. Okay, the opposite of that is the kind of interval we had up above. Okay, it's called a half-open interval. Fully open interval, where parenthesis is on A and a parenthesis is on B, which means you cannot use either A or B as part of the answer. And depending if you're more optimistic or pessimistic, you have a half-open interval. I guess you could also say half-closed. Half-open. This one is half-open on the right. And this one is half-open on the left. Okay, so any questions on the 4 types of bounded intervals? If you look at page 99, they actually draw a sketch with each one. Okay, so they show you a number line and like how you would shade on it. So when we do it on a number line, you have 2 choices. If your interval is open, you can use the parenthesis, or what kind of circle could you use on a number line? If you were graphing, Sam? You could use an open circle. Same thing with the bracket. If it's closed, you could use the bracket, or you could use a filled-in circle. Okay, when you're graphing on a number line. All right. So in contrast to bounded intervals, we also have unbounded intervals. So an interval is unbounded if it has the infinity or negative infinity symbol. These are unbounded. And with an unbounded interval, you always put a parenthesis on infinity. Okay, so those are the 4 different types of intervals you could have that are unbounded. Okay, in the 2 on the left, okay, they are both unbounded on the left, but one is closed on the right, one is open on the right. In the other example, they're both unbounded on the right, but one is closed on the left, one is open on the left. So combining this with what we just went over, could you have a, let's see, an unbounded interval that's fully closed? What do you think? Sam, how come you're saying no?
Because you can't have 2 brackets because of the infinity.
Right, if you have an infinity, you've got to have a parenthesis, which means it can't be fully closed. Yep. Good. And they show the same kind of thing in your book on page 100, what it would look like if you were to graph on a number line. Big difference when you're graphing an unbounded interval is there's an arrow. It goes on forever. Bounded intervals have a start and a stop. All right, so let's take this and write an inequality to represent this interval. Okay, so this is called interval notation. We're going to rewrite it as an inequality. Okay, and we'll use x as our variable. Okay. Well, Jane, could you think you could give me what that inequality would be that would represent that?
-3 is less than x.
Yeah, good start.
And then x is less than or equal to 5.
Perfect. -3 is less than x, which is less than or equal to 5. That's it. Any questions on that? So you might have to do both. You might have to convert from an inequality to a interval notation, or what we just did, interval notation to an inequality. All right, let's try this one. So it's a half open interval. It's unbounded. And I want to write that as an inequality. Right, Trevor, do you think you could tell me how to write that one as an inequality?
-4 is...
How about, let's try something a little different. Start with your variable. Let's say x is...
less than or equal to -4? Greater than or equal to?
Greater than or equal to, right? Because this means you can pick any number from -4 up to infinity. So x is greater than or equal to -4. So not every inequality has to be a compound inequality. This one's not. Unbounded intervals are not, you don't write them as compound inequalities. Okay, let's try this one. First of all, how about Juliet, can you tell me what type of interval this is? It's a bounded interval. Can somebody else tell me one more thing about it? It's bounded and it's fully closed. Yeah. If you said that it is bounded, does that automatically mean it's fully closed? No. What if you said it's fully closed? Does that automatically mean it's bounded? Yes. Because if it's closed on each end, that means you don't have an infinity, which means it has to be bounded. Okay. Somebody tell me how you would write this one. Yep, Rebecca.
X is greater than or equal to -8.
Like this? Yep, okay, yeah, we could do that.
And X is less than or equal to -3.
So X is greater than or equal to -8, and X is less than or equal to -3. Yep, that works. Can anybody take what she said and combine that into one inequality? But that is correct. Yeah.
-8 is less than or equal to x. X is less than or equal to -3.
Yeah. Perfect. Hey, any questions on that? Yeah.
How did you get the -8 to be less than and the -3 to be greater?
Because this interval means between, so you have to pick numbers that are between -8 and 3. So to be between it would have to be bigger than or equal to -8, but it would also have to be smaller than -3. Yeah. So bounded intervals, you can think of them as a between. That's what they mean. All right, let's try one with a graph. You got an number line. You don't have to number the whole thing, just number enough so that I can see the point that you're going to be graphing. And we have a choice. We have two choices for symbols you could put on the tube. Tessa, what's one symbol you could use on the tube? The circles, yeah, so that's one choice. What type of circle could you use? Closed? Or what kind of bracket or parenthesis if you wanted to do it that way? You could do a bracket, so we could do it either way. Let's do the bracket and parenthesis, since that goes along with interval notation. To use the bracket, you have to already know which way you're going to shade, because the bracket has to face that way. So Leo, which way am I going to shade this time?
To the right.
To the right. So I'm going to shade right. And that's it. So that's x is greater than or equal to 2. Let's try x is less than 5. how about Shauna? What kind of symbol would we put on 5? Parenthesis or open circle. If you do a parenthesis, which way would it face?
To the left.
To the left. Perfect. So parenthesis, and we're going to shade 5. Any question on that one? Okay, let's take a look at this one. So Dylan, what's going to be the big difference between C compared to the A and B?
It's not going to go on forever, it's going to stop.
Yes, it's going to stop. It's not going to go on forever. Perfect. And Gracie, can you tell me where, or what kind of symbol I would put on -1? Careful, not on the -1.
Would it be a circle? Like the.
Well, we are going to use the brackets or parentheses, but in this case, the -1 is a bracket.
Oh.
Can anyone explain why it's a bracket and not a parenthesis? Yep, Julie.
Because it's equal to or
Less than, yeah, it's got the equal to symbol.
Yeah, it has the equal to.
So anytime you have that, we got to use a bracket. I didn't ask which way, but this is a between, so they have to face each other. So bracket on -1. Sam, what about on 3? Good, parenthesis. And we're going to shade between, and as Dylan said, it doesn't go on forever. So any questions on that one? All right, so not too bad. These are all pretty straightforward so far because the variable was already by itself. You didn't have to do any work to isolate it. So if you do have to isolate it, you pretty much use the same steps as when you're solving an equation. But does anybody know what you have to be careful about with inequalities? It's kind of a hint on the board, but I didn't fully write it out. Yeah, Jane?
When you divide by a negative, you have to flip the sign.
Yeah, when you multiply or divide each side by a negative, you have to flip the sign of the inequality. Okay, so that's pretty much the only thing that's different about solving inequalities. You multiply or divide by a negative, flip the sign. All right, so in Algebra 1, I would probably start off with one quite this complicated with distributive and everything, but we should be able to solve that pretty quick. So Megan, if I'm going to solve that, what would be my first step?
Distributing within 3.
Yeah, perfect. We're going to distribute the 3. So I get 3x minus 3 plus 2 less than or equal to 5x plus 6. Leo, what would be my next step?
Combine -3 and 2.
Yep, and that would give me -1. Now, in this step, if I want to avoid a negative in front of x, what side should I put my x's on? Yeah, Rebecca? The what side?
The right.
Yeah, I would put them on the right side. So how would you move the 3x to the right? Subtract. And if we're going to put the x's on the right, let's move everything else to the left. That's not an x. So that's going to give me -7 is less than or equal to 2x. And now, because I avoided the negative in front of x, I'm not going to have to flip the inequality. I might rewrite it when I'm done so that the x is on the left. But my last step is to divide by 2, which is a +2, so you don't have to flip anything. Okay, so you could write it that way. Or how would you write it if you want the x on the left? Yeah?
You're right, x is greater than or equal to 7 halves.
Yep. So what we just did there has nothing to do with flipping the sign because we divided by a negative. I just flipped the problem around because we usually like the variable on the left. Because now if you have to graph it, the inequality symbol tells you which way to shade. Okay. Right. Any questions on that one? So now we're going to look at solving on the graphing calculator. And there's really two methods. And the two methods have to do with either calculating a root or an intersect. Depends on how you type it in. We've kind of done this before. If you get the inequality equal to 0, okay, or if it's an inequality already equal to 0, we can use the root feature. Okay, that'll be the first method. And then after you figure out what the root is, the answer is either going to be everything less than that root, okay, if the symbol was a less than, so you're going to be looking at the negatives, or it's going to be everything greater than that root, or it could be equal, depends on the problem. Right? But that's how you do it. You find your root, and your answer is either everything below that root, or everything above that root. Again, or equal to it, depends. Any questions on the general idea of what you would have to do if you're going to calculate a root? All right, let's try it, and then I'll show you method 2 after. Okay, so this one we're going to get 0 on one side. Well, Abby, how would I get 0 on one side?
Subtract 2.
Okay, subtract 2, subtract 2. Now, because I subtracted, should I flip? Flip the sign, Trevor?
No.
No, we don't flip the sign when we subtract, only when you divide or multiply by a negative. Okay. So now, we've got 0 by itself. We're going to type in 4x minus 3. Okay. Put that in y1. And then do zoom 6. Now what we're looking for is where this graph is less than 0. Okay. Where is it below the x-axis? Okay. So your answers are basically everything in that section for x values. So we're going to be looking for that point that I circled and to the left. Because if you plug in any number to the left of that, your graph would be below 0 for the y value. All right. So you could probably tell just by, if you just add 3 and divide by 4, you get 3/4. Yeah.
So since it's less than, it's just everything to the left.
Yep, it's going to be everything to the left because if you plug in an x value to the left of 3/4, it's going to be below 0 for the y value. But I'll go through second calculate intersect. I'm sorry, second calculate 0. So pick a point somewhere to the left. Do the right. Guess doesn't matter. And we get 0.75. So we want to plug in anything less than 0.75. If you plug in something bigger than 0.75, let's say you plug in 2. Well, if you plug in 2, you're going to get a value up there. That's not going to be less than 0. It's going to be more than 0. Okay. So that's the first method for solving a inequality on the calculator. Any questions on that method? Second method. The second method involves not getting it equal to 0, just graphing what's on the left in y1, put what's on the right in y2, and then calculate an intercept. But it's still the same idea. Once you find the intersect, your answer is either going to be everything below that or everything above that. So we're going to do the same problem we just did again, but this time I'm going to do it as an intersect. Okay, so the advantage here is you don't have to rearrange anything before you start. You can just leave it the way it is. So let's try it this way. So I'm going to put 4x minus 1 on the left. I'm going to put 2 on the right. The standard window is perfect. It's big enough. And now the graph of 4x minus 1, is that the blue line or the red line? The blue line. So what I'm looking for is where, basically if you want to kind of visualize it, I am looking for where the blue line is less than the red line. Okay, that's what I'm looking for. Okay, what x values would that happen at? So second, calc, intersect, point on the blue, point on the red, and the guess, again, it doesn't really matter. And they intersect at 0.75. So would I want everything above 0.75 or below? Sam?
Below.
Yeah, below. We want x values that would cause the blue graph to be below the red graph. Those are the values below 0.75. If you pick a value above 0.75 for x, then the blue one is going to go above. And that's not what they want. So any question on how to solve a linear inequality with this method, either doing an intersect? And if the directions say to solve on a graphing calculator, it doesn't matter which way you do it. You could do it either way. All right, let's take a look at a double inequality. So same goal, when you have a double, like a conjunction, you want to get x by itself, but now you don't have like a left side and a right side, you have 3 parts. You have a left side, a middle, and a right side. So whatever you do to the middle, you have to do it on the left, and you have to do it on the right. And the same rule applies. If you multiply or divide by a negative somewhere, you have to flip all the inequality signs. So that inequality would be relatively straightforward. You just divide everything by 2. And you get negative 4 is less than x, which is less than 6. When in doubt, if you have trouble getting x by itself, you can always use the graphing calculator. Okay? And the idea with the graphing calculator would be put that in y1, put that in y2, put that in y3. And then what you'd be doing is on the screen, you would look where the graph for y2 is sandwiched between y1 and y3. That's what you'd be looking for. So this particular graph would have something like this. Horizontal line at -8, horizontal line at +12, and then a line with a y-intercept of 0, slope 2, something like that. And you would be looking for all x values between those 2 points. I guess technically it would be open. So it would be the x values between those two, which would be between -4 and +6. Okay, let's try this. Okay, so graphically, you could take the same approach I did last time. Look where the middle graph would be sandwiched between -3 and 5. But we're gonna try to solve it algebraically. Tanya, what would be my first step here to start to simplify what's in the middle? Yeah, let's multiply everything by 3 times 3 and times 3. So that's going to give me -9 on the left. Sam, what will that give me in the middle?
2x plus.
Good, 2x plus 5, less than or equal to 15. How about Rebecca, what would I do next?
Subtract 5 from all sides.
Yep, just like solving an equation. Subtract 5 from everywhere. -9 minus 5 gives me -14, which is less than 2x, which is less than or equal to 10. And Leo, what would my last step be?
Divide all three parts by 2.
And is that a positive or a negative? It's a positive, so we don't need to flip anything. So my final answer is -7 is less than x, which is less than or equal to 5. Megan, could you tell me how I could write that as an interval instead of an inequality?
Parentheses -7, and then 5, and then bracket.
Perfect. For the context of what we're doing, if you had an open interval on each end, we know it's not a coordinate, it's an interval, because we're studying intervals. Of course, if you have a bracket there, then it's clear that it's not a coordinate. Okay. It's the only disadvantage to interval notation. Some people might confuse it with a coordinate. All right, let's take a look at this one. So it says, and we've done problems about rectangles before, okay, so it's going to be similar. But I want you to think about all the different rectangles where the length is 1 unit more than twice the width. Let's write that down first. How would you write that down as an equation? The length is 1 unit more than twice the width. Yep. Okay.
2w plus 1.
Yeah. So at some point, we're probably going to do a substitution for length. Length is 1 unit more than twice the width. Find an algebraic representation of all those rectangles with a perimeter less than 100. Okay. So here is our rectangle. And the length we don't know, so we'll just call it L and L. And the width we don't know. But what can I substitute for there? Yep.
You can substitute 2w plus 1 for the length.
Yeah, so we'll call that 2w plus 1. And that's also 2w plus 1. So what's the perimeter of that rectangle? Leo?
A number less than 100.
What is the perimeter of that rectangle?
Less than 100.
Okay, it's going to be less than 100. But what would be like using our values that we've labeled here? What would be less than 100?
2w squared plus 1. Wait, no. No. Uh, 6w plus 2.
Right, so the perimeter is 6w plus 2. And Leo just said that that has to be less than 100. So you want your perimeter to be less than 100. That's basically what we're setting up. So find an algebraic representation of those rectangles with perimeter less than 100. There you go. Part 2. Find the possible widths of the rectangles. Okay, so now solve the inequality that you just created. So 6w plus 2 less than 100. Sam, my first step to solve that?
Subtract 2.
All right, so subtract 2. So 6w is less than 98. And Juliette, my last step.
You divide by 6 on both sides.
Divide by 6. Divide by 6. So we get that the width has to be less than 16 1/3. So we'll just say 16.33. And I think that was in inches. Yep, inches. Okay. Anything else I need to put with that answer? Because the way it's written there, that's kind of incomplete. Yeah?
Should it be less than or equal to?
Oh, was it less than 100 or less than or equal to 100? No, less than.
Oh,
That's okay.
fine.
Less than. But still something else I need there.
Would you have to put that w in 0?
Yes. You also have to put w. So what you could do is you could write your answer like this. So 0 is less than w, which is less than 16.33. Because technically, if you say the width is less than 16.33, -4 fits that. Okay. If you forgot to do that, you'd lose like a point for forgetting that. Okay. Questions on that? All right, so absolute value inequalities. Very, very similar to absolute value equations. Okay. First thing you have to do is get the absolute value expression by itself, and then you're going to split it into 2 problems. The first inequality is going to be exactly the same as your original. The only thing you're going to do different is get rid of the bars. Okay, so you're going to get rid of your absolute value bars. Now, yesterday when we found the second equation, what was the extra step? You had to copy down the original, get rid of the bars, but what else did you have to do in your second equation? Caleb, do you remember?
Flip the sign.
Not yesterday. We're going to talk about that today. But you had to do one other thing first. Because yesterday we just had equations, so we didn't have anything to flip.
You have to negate the other side.
Yes, you had to make the number on the other side the opposite sign. So we're still doing the same thing, but since we're making something negative, we have to flip the sign with it. So the second inequality, same as the original, take out the bars. You still make the number on the other side negative. That's all the same as yesterday. But you also have to flip the sign. And the last thing is when you write your answer, Now we have a choice. Okay, and I told you yesterday I'm going to be a little more picky about if you put and or if you use the word or. Okay, whether you use and or, it all depends on the symbol in the original problem. If the original problem contains a less than or a less than or equal to, okay, you're going to use and. And the way I remember it, if your original problem has a less than, you use and. Okay, less than uses and, so think of like land. If you have a greater than, or a greater than or equal to, it's or. That's all I got. I don't know. So you just have to remember that greater than uses or. Right? However you can remember it, that's all. Now, you use the words and or if you're writing it as an inequality. If you're writing it in set notation with brackets and parentheses, then you use these symbols. We use the intersect, and I think we've used the union symbol before. Like when we have this or this interval. You can kind of think of an intersect, it's like an overlap. It's an overlap. Right. Let's see if we can solve. We can graph that. We've graphed absolute values before. What shape is an absolute value function? Remember, Jane?
V.
Yeah, it's a V shape. So one way to do this on the calculator is to graph the absolute value in y1, graph that in y2, and you're looking for where the V shape is below 3. Right, so it might look something like this. So you have to find 2 intersects. That's why there's 2 answers for x. Okay, but we'll go through it algebraically. Can someone give me my first inequality that would split into? Sam? Yep, that's part of it. Anything else? Nope, we still need more because we don't have an inequality here yet. We got to have a less than, greater than.
Would it be less than?
Less than
3.
3. Yep. So x minus 3 is less than 3. Okay. Original symbol is a less than. Am I going to put and, or am I going to use or? Sean?
And?
Yep, and. And how about my second inequality? Crazy?
X minus 3 is less than negative.
So x minus 3, that's good. Negative 3 is good, but what do you have to do with that sign?
Flip it.
Flip it, so it's going to be greater than. Yep. And now solve each one. So x is less than 6. And, so this is a between. We're going to be less than 6 and greater than 0. Okay. Any question on that? So the key is to always make sure, I think I wrote it yesterday, and put it up here. You have to make sure the absolute value expression is by itself first. If you had, say you had something like a 3 in front, what would be your first step here? Yep.
Divide by 3.
You would divide by 3 first. Okay, and that would cancel the 3, and because it's a positive 3, you don't flip anything. If you divided by a negative, you would flip. Okay, so sometimes in these problems, you can end up flipping a couple times. Depends if you have a negative there or a negative out front. All right, so we're going to see some problems that say something like, write an inequality for the following. And it'll say something like, x is less than 3 units away from 10. So if I asked you to give me a number that was less than 3 units away from 10, you could say, well, I could do something as low as 7. That's within 3 units of 10, and as high as 13. So what that would look like is a between, right? Between 7 and 13. So I use an less than for an and we could set it up like that. If you wanted x to be within a units of some point. So inside the absolute value is what you want to be away from. The a is how far you want to be away from it. Okay. So let's try this. I want to write an inequality that represents all values that are within 4 units of the origin. So what number would we use to represent the origin?
0.
Yep, I'm going to use 0. So you could basically say within 4 units of 0. So remember, inside the absolute value, that's what you want to be away from. And that's how far away. So anyone think they could give me an absolute value here that would be represent all numbers within 4 units of 0? Yep.
X is 0 is less than 4.
Yeah. And in that case, it's really just the absolute value of x is less than 4. That represents all numbers within 4 units of the origin. So between -4 and +4. All right, let's try this one. X is within, same thing, where x is less than 3 units from 2. What would be my absolute value for that one? X is less than or within 3 units from 2. Crazy?
We also find x minus 2 less than 3.
Yep. Inside is what you want to be away from. And 3 is how far away. How about this one? X is at least 5 units from -3. So we've gone from like a less than, or we can say x is greater than or equal to 5 units from -3. Anyone think they could tell me this one? Rebecca?
Absolute value of x minus -3. And then the greater than or equal to sign.
Yep.
5.
Okay. So this is going to be an or. If you want to be at least 5 units away from -3, well, you could pick, basically, here's -3, and this represents 5 units away, and that represents 5 units away. You could pick anything in that direction, or you could pick anything in that direction, at least 5 units away. Okay, so that's why we use a greater than, and that would be an or problem. Opposite directions, no overlap. All right, we're going to graph one on the calculator. Well, maybe we have time to do both, I guess. So there's two left, and they're both graphing. This one's a little bit harder, so we'll spend a little more time on that one. But let's just try this one. Okay, we'll split it into 2. Megan, can you give me one of my inequalities?
3x minus 2 is greater than 1.
Perfect, greater than 1. Leo, do I use and or?
Or.
Yep. greater than is an or. And Abby, can you give me my other inequality?
3x minus 2 is less than negative 1.
Perfect. All right, so we're going to get 3x is greater than 3, or x is greater than 1. X is greater than 1, or 3x is less than, I'm going to add 2. So we get 1, and then divide by 3. So x either has to be greater than 1 or less than 1/3. So it almost covers the whole number line, but not quite. Okay. For example, 0.5 would not be a solution. 0.5 is not bigger than 1, and it's also not less than 1/3. Any questions on how you would graph it? Just type what's on the left in y1, put what's on the right in y2, and then you're going to get a V shape. And in this case, you would look for where the V shape is above 1. So it would be something like that, and you would get this number in that way, and that number in that way. And the two numbers you would get are 1 and 1/3. Those would be the two roots you would calculate. Or I'm sorry, intersects. Because the x-axis would be somewhere down here. Something like that. That's not perfect, but that's the idea. Any questions on that? All right. So let's finish up with this one. Okay, so we have x plus 3 divided by the absolute value of x minus 2. What are they asking about this? They're asking when the thing that I just circled is what? Trevor?
0. 0.
No, they're not asking when that's 0. Yeah? They're asking when it's greater than 0. So, what determines when you do division if something is greater than 0 or less than 0? How could something come out less than 0 with division? What would have to happen? Sam?
Divide by a negative.
Divide by a negative, either on the top or on the bottom. Okay? So in order for this to come out greater than 0, we just have to make sure that we don't have any negatives, either in this part or this part. Any thoughts about the bottom coming out to be negative? How could the bottom come out negative? Sam?
It can't.
It can't. The bottom can never be negative because it's absolute value. So that is always going to be a non-negative number. So the only thing you really have to worry about in this whole problem is the top. That's the only thing that could cause this fraction to ever come out less than 0, which is what we don't want. So all we have to do is figure out when the top is greater than 0, because the bottom always is. So what would be the solution? As long as you pick an x, that's what? Jane?
Anything greater or equal to -3.
Anything what?
Greater than or equal to.
No equal to.
Just greater than.
Just greater than, because there's no equal
Yeah.
to there. Yep. So anything greater than -3. Almost. You've got to be careful. Yeah?
You can't do 2.
You can't do 2. So you can pick anything you want that's greater than -3, but you can't pick 2. How come?
It would make it 0.
Right. You'd be dividing by 0. So let's graph that and see if we can kind of confirm what we just got. When you type this in, use parentheses around the numerator. Divided by, remember, absolute value is under math and then number. X minus 2. So we are looking for where this graph is above the x-axis. And that red line you can ignore, that's from a different problem. So I can see that as I start off to the left, it's definitely below. And at some point, it crosses. It crosses the x-axis. Where does it cross? It crosses right at -3. Okay, so there's your -3. And notice if you try to plug in 2, the graph is going up very high right there. Okay, if you want to see how high it's going, you can go to your table. Don't plug in 2, because that'll give you an error. You can't do that. But plug in something very close to 2. The y value is almost up at 5,000. So how high do you think it's going there? Kidding?
Is it going infinitely?
Yeah, it's going to go up to infinity, both just before 2 and just after 2. Okay, just after 2, it's up at 50,000. So it's up very, very high. And then the graph starts coming back down. Okay? And there might be a question, does it come back down and ever go back below the x-axis at some point? Well, what I would do is check some big values for x, like 50. Nope, it's still above 0. 500, still above 0. Let's check 99,999, still above 0. So if I've gone all the way out to almost 100,000 on the x-axis and it still hasn't come back down below 0, it's probably not going to. So our graph confirms exactly what we got. Everything from -3 and up, not including 2. Now, last thing, how would you write that as an interval? If they could tell me how to write that. You're going to have to write it as 2 intervals. Okay? Because if any time there's a value you're not allowed to use, that's going to be like a bound. That's going to be an endpoint of one of your intervals. About time? Do you have an idea how to start off? Well, what's our lower limit here? We can't go any lower than what? Can't go any lower than -3. Can we include it?
No.
No. So from -3, what can you go up to before you have a problem? Yep. Can you include 2? No. So you can go up to 2, but don't include it. Or now you could go from what number as high as you want. Yeah.
Greater than 2.
Greater than 2, so from 2, not including it, up to infinity. That's how you would write what we just wrote up here as an interval. Okay. Any questions on that? All right, so homework tonight, just thought it's on one page. It's all on page 108. It might go on to 109. and it's 5 through 7, 10 and 11, 14 through 16, 19, 20, 22, then 24 to 26, 29, and then on 34 to 38, just the evens. Okay, don't do all, just the evens. Then 42, 43, 49, and 60 to 62. Okay, some of those are connected, like 60 to 62 is all the same problem. So it's not really 3 separate problems. Okay, so we'll take a look at that tomorrow and then go over it. And we will finish chapter 2 tomorrow. Be done.